Hey everyone, and welcome to this explainer on the Model Context Protocol, or MCP. Today's AI models are undeniably brilliant, but they all share one pretty glaring flaw. They are entirely trapped inside a text box. Sure, they can write you a beautiful, descriptive poem about a vacation to Italy, but they can't actually go and book that flight for you. Well, today we're diving into how MCP is stepping in as the missing link for AI action, finally breaking these models out of the chat interface so they can actually get things done in the real world. Think about it for a second. How does a chatbot actually book a flight? If you just type out, "Hey, fly me to North London," the AI can't just generate a bunch of text and call it a day. It has to query third-party airline APIs to pull live pricing and availability, cross-reference all of that against your personal seat preferences stored in some database, and then actually execute a secure purchase. It has to keep working, keep checking, and keep doing things until the job is actually finished. And this perfectly highlights a massive shift we're seeing right now in the industry, the jump from passive LLMs to active AI agents. A passive model just sits there waiting for your prompt and spits back text. But an active agent, it investigates, it checks its own memory, it reaches out to external tools, makes conditional decisions based on what it finds, and essentially loops back and forth with the underlying model until your specific objective is fully achieved. Historically, though, getting an AI to actually talk to the real world has been a developer's absolute worst nightmare. We're talking duct-taped custom automation scripts everywhere. One airline uses a flights endpoint, another uses a flight list endpoint, and developers were just forced to rely on Zapier or write this incredibly messy Python spaghetti code just to stitch it all together. When you consider there are millions of software services out there, writing bespoke custom code for every single API is just a total dead end for scaling. And this is exactly where the Model Context Protocol steps in to save the day. The easiest way to grasp this, think of MCP as a universal translator for AI applications. It's kind of like a USB port. A USB port lets you plug almost any piece of hardware into a computer without having to rewrite the motherboard software, right? In that exact same way, MCP gives AI a single standardized way to communicate with any external tool. So, strictly speaking, MCP is a standardized protocol for AI models to securely access external tools, resources, and systems. But in practice, what it really means is build it once, run it anywhere. If an airline goes ahead and builds an MCP server, well, any AI client that speaks MCP instantly knows exactly how to book tickets through them. It is absolutely a game changer for scale. Okay, let's break down the architecture a bit, and a great way to picture this is by thinking of the electrical setup in your house. The MCP client is basically the wiring inside your walls. Its only job is to just reliably carry a connection. The MCP server, on the other hand, is the appliance you plug in, like a lamp or a toaster. The wall wiring doesn't care at all what's plugged into it, it just passes the current along. It's the same thing here. The client simply passes the requests, while all the heavy lifting and specific business logic lives securely over on the server. For your actual daily workflow, this setup is incredibly powerful. Your host application, whether that's Claude Desktop or an IDE like Cursor, acts as the client, and it can actually connect to multiple MCP servers all at the same time. This means your one single AI assistant can instantly query your CRM for customer records, hit a billing server for invoices, and check a support server for tickets, all simultaneously. You're adding massive new capabilities to your AI without having to, rewire the whole house. So what is an MCP server actually handing over to the client? It basically breaks down into three core things. First, you have tools. These are the direct actions the AI can execute, like a search flights command. Second, you have resources. This is the raw data or context the AI reads to make its decisions, like looking up API documentation. And third, you have prompts. These are predefined instructions that give the AI very specific behavioral guidelines for the task at hand. Now, for the builders tuning in, you might be wondering how the client and server actually talk to each other under the hood. Well, it's refreshingly simple. It uses JSON RPC version 2.0. It's basically a very lightweight, stateless remote procedure call, encoded entirely in JSON. The client just sends over a JSON document with a method, and the server returns the result. Because it strips out all the unnecessary bloat, you can implement this stuff incredibly fast. And because that communication is completely stateless, you get total flexibility on the transport layer. For instance, you can use standard I/O or STDO for running local servers right there on your machine. That's highly isolated, lightning fast, and perfect for desktop apps. Or let's say you have a massive cloud database that your entire team's AI needs to ping. You can just connect to that remotely over the network using standard HTTP. And honestly, the best part of all of this? You don't have to wait around for this to become a reality. There are official, ready-to-use reference servers available right now. You've got a file system server for reading local files, a Git server so that AI can manipulate your repositories, a fetch server for scraping and reading web content, a time server, and even an everything server, which is built specifically for developers to just test out their setups. Setting this up is also ridiculously easy. Let's say you want to connect the file system server to Claude Desktop. It is literally 4 steps. You open your configuration JSON file. You add a quick npx command that points to the file system package. You explicitly tell it which local directories it is allowed to see. And finally, you just restart Claude Desktop. A little hammer icon will pop up on your screen, and boom, you are connected. Once you're connected, that is where the real magic happens. You could just type into the chat, "Hey, please organize all the images on my desktop into a new folder called Images." Because Claude now has access to your file system tools through MCP, it will literally scan your actual desktop, create the new folder itself, and move your files for you. The AI isn't just chatting with you anymore. It is actively working on your local machine. Now, I know what you might be thinking. If the AI can move files around, what else can it do? Security is absolutely paramount here. The hard and fast rule is that the server only runs with your specific user account permissions. More importantly, all actions require your explicit approval before they execute. So when Claude decides it wants to move a file, a prompt will pop up asking for your permission first. You are always the human in the loop. If just feeling inspired and want to start building, the great news is that MCP is entirely language agnostic. Microsoft actually has an open source MCP for Beginners curriculum on GitHub right now, and it provides real-world examples in TypeScript, Python, C#, Java, and Rust. So whatever ecosystem you happen to prefer, you can literally start building today. And keep in mind, this standard is evolving really rapidly. If we look ahead to the upcoming 2026 specifications, we're already seeing planned upgrades, things like a fully stateless transport layer across the board, a formal framework for extensions, and some heavily hardened authentication protocols. This is definitely not just a fleeting trend. We're looking at the foundational plumbing for the entire future of AI. By standardizing exactly how these models talk to external tools, MCP completely eliminates that massive bottleneck of writing custom API integrations. We are officially moving from passive chatbots to active AI agents, agents that can reach right into databases, navigate file systems, and browse the internet to get actual work done. So I will leave you with this one thought. With the Model Context Protocol finally giving AI a standardized way to interact with the real world, what will your AI agent build tomorrow?